Please title these notes Derivatives 10 Notes, Prerequisite, Composing Functions, and write today's date. By the end of this lesson, you should be able to compose functions and identify what functions were used to make a composed function. Let's start off with evaluating functions. Which is the precursor to composing them. And let's imagine that we have a problem like this. If f of x equals 3x squared plus 4x, find f of 5. The idea with a function like f of x is that this x just really stands for anything. It's basically a little box that we can put anything that we want to into. So I'm going to replace each of these x's just with a little box. And when I'm evaluating this, I'm taking this 5 and I'm just putting that into each box. Once I've done that, I just simplify like normal. F of 5 equals 3 times 25 plus 20. F of 5 equals 75 plus 20. F of 5 equals 95. Let's practice that with a second problem, then we'll go on to composition. If, let's call it g of x this time, equals 2x minus 4 over x, find g of negative 1. I'd like you to try this on your own for just a second, so pause the video. When you're ready, restart the video. Again, this x just represents a box. So I'm going to replace all of the x's with boxes so that I see that I'm just going to be putting this into those boxes. Whoops, that's a minus sign. And now I take my negative 1 put it into each box. Just like that. Composing functions is the same idea. Let's say we have a problem like this. We've got f of x, which is 3x squared plus 4x, and we've got g of x, which is 2x minus 1. And our problem is to find, actually this should be letter A right down here, find g of f of x. This can also be notated as g open circle f of x, but I think this notation makes a lot clearer what's going on. So again, we're starting with this g of something, and it's basically just that box again. And we know that our g function here is 2 times whatever's in the box minus 1. And all that this is saying right here is that what's inside the g function, inside the g box, is this f of x. And we see right here what f of x is. So the f of x here is going on the left. What it is going on the right. Just like what we were doing with numbers earlier, but now we're doing it with a whole function. So this gets us to g of f of x, which is what we want to find. Just distribute that to 6x squared plus 8x minus 1. And there we go. Going the other way, we could also find f of g of x. And here our outside is the f. So we're going to use our f function with the box. And our f function right here, I'll color code it. It's 3 box squared plus 4 box. And what's going in that box? Well, it's this g of x right here that we have up here. So just like we did up here, this g of x is going to come in here. G of x is 2x minus 1. X minus 1 goes in the box. Notice in this case there were two x's in the original f of x equation, so that means that g of x goes in there to both boxes. F of g of x equals, so this is squared, so we should do the square. 2x minus 1, 2x minus 1, 4x squared minus 2x plus 1. So this is 3 times 4x squared minus 4x plus 1. We can distribute this 4, 8x minus 4. We can distribute that 3, 12x squared minus 12x plus 3. And we can combine like terms. 12x squared minus 4x minus 1. And there's our composition. Go back and make sure that you are super comfortable doing these types of problems right here. If need be, put your notes aside and go back and redo the problems a couple of times on your own. You need to be super solid on this for what we're going to do next. For the next objective, it is going to be extremely important to be able to identify composed functions. What we're doing here is we're going the other way. We're taking a function that's been composed, we're breaking it apart into its component functions. And there are a couple steps for this. The first step draw any box functions. And I'll explain to you what a box function is in just a second. If there is one, though, if there is anything except x in the box, when you draw it, then multiple functions have been composed. So here are the box functions. They are power functions, that's anything raised to a power, so the variable is right here. This is any number. Also exponential functions. So that's e, there'd be a variable in here. That's the most common one, or really any other number. But the key thing is that there's a variable in the exponent. Other box functions are trigonometric functions. So that's sine of something, cosecant of something, etc. So there are 6 of those. The variable is going to be right in there. Notice this is not sine times box, it is sine of box. These two things cannot be separated. And then the final box function is logarithmic. So the most common is ln, but really it can be log any number. Well, the base has to be greater than 0 in order for the logarithmic function to be possible at all, but any number that's there to begin with will be fine. And again, the variables are in the boxes. That's going to be the first step. The second step is simply going to be to write the functions outside and inside the box separately. So let's give an example of what this looks like. If f of g of x equals the natural log of 3x plus 1, identify f of x and g of x. Okay, so the first thing to notice here is that we have f of g of x. This is a composition. That means there's going to be an outside function and an inside function. The first thing we're going to look for are our box functions here. So any of these. So look through and see what's in the problem. Notice natural log, ln, right there. That, whatever is next to it, especially inside these parentheses, this is a box. So what this means is it means that we have an outside function. I'll do that in red. Which is this ln box. Basically, I'm going to ignore what's inside the box. I'm just going to write ln box. Notice that this f is also my outside function. So the outside function is f. It's called f of x. And it's just going to be ln box. Remember, the x just stands in for a box. So there's my function. If you wanted to write it as f of box equals ln box, that's okay, but this is the formal notation for it. So there's one of my answers. And then I can also look at what's inside. So I'm just care about what's inside that purple box there. I can see that that's 3x plus 1. There's already an x there. And notice that the inside function right here was g of x. So that means that g of x equals what's inside 3x plus 1. Notice that if we check our work, f of g of x, so we're just going to compose it. That's going to be f box equals ln box, and then the g of x gets put inside the two boxes. And I said g of x was 3x plus 1. Lo and behold, we're right back where we started. Okay, so let's do some practice with that. If f of g of x equals 2x plus 5 to the third power, identify f of x and g of x. So the first thing I look for here are any of my box functions. Notice that anything to a power is a box function. So that means I've got a little box right here. The parentheses are also a really good thing to look for. Frequently you've got a box where you have parentheses. So now we're going to split this into our outside. So I'm not looking at what's in the box, it's just I can see this is box to the third power. F is my outside function, so we're really saying f of box equals box to the third, or f of x equals x to the third, because we're asked to find f of x. So there's one of my functions. Now we're looking at the inside, and I can see that what's inside the box is 2x plus 5. My inside function is called g. So there's g of x. That's it. Let's have you try one on your own for practice. If f of g of x equals sine of 7x, identify f of x and g of x. Okay, pause the video, try to do that one on your own, and when you're ready, restart the video. Okay, first we're looking for box functions. Trigonometric functions are box functions, so whatever's right next to it goes in the box. We're going to do our outside function first. Outside is f. So we've got sine box. F of box equals sine box. We're looking for f of x, so f of x equals sine of x. Looking at what's inside. Inside the box is 7x. There's already an x there. Our inside function is g of x. So g of x equals 7x. Now, in addition to doing this, we can also do multiple compositions. So So let's say that we had something like if f of g of, I'll bring purple into play here, h of x. So now we've got 3 layers here. Let's say that that equals cosine squared 5x minus 2. Now the first thing to note is that we need to rewrite this. This means cosine squared of 5x minus 2, which is the same thing as cosine of 5x minus 2, that whole thing squared. Oh, our directions are to identify f of x, g of x, and h of x. This is the same thing as writing f of g of h of x equals cosine 5x minus 2 whole thing squared. So we're going to have 3 different functions to pick out. Let's just start at the outside and work our way in. The first or biggest box function that we see is that we see a squared power function. So that means that this whole thing right here, that's all a box. And if we're working on our most outside level, f of x, we're just talking about something squared. But what makes this different is that when we come to look at the inside function, notice that we still have a box function. Inside is cosine 5x minus 2. But cosine is a trigonometric function. It has a box itself. So that means our next layer, we've already taken out f, so our next layer is g. That's cosine of something. G of x is cosine of x. Now h of x is purple, it's the inmost layer here. So we're looking at what's inside the final box. This is just 5x minus 2, so h of x equals 5x minus 2. Go ahead and try this yourself on the next problem. If f of g of h of x equals e to the sine of 4x, find f of x, g of x, and h of x. Okay, pause the video, go ahead and try that. Okay, so working from the outside, we want to make the biggest box possible. We know an exponential function is a box function, so we've got one box right here. This is e to the box, so that means that f of x is e to the x. Now, inside we've got a sine of 4x. Again, there's a box function. Our next layer is blue, it's g of x. So we've got a sine box. So that means g of box equals sine of box, or g of x equals sine of x. And then finally, inside that last box, we've got a 4x, so h of x equals 4x. And there we have identified the 3. If we were to go the other way and compose them all in, h of x would go into sine of x, so it would be sine of 4x. Sine of 4x would go into e to the x, so it would be e to the sine of 4x, which is what we started with. Sometimes it can be hard to tell whether or not you have multiple functions. So here's one thing to be really aware of. If you draw a box and only x is in it, it doesn't need its own function. So for example, let's say y equals 3x squared plus 4 all to the 5th power. And I'm not telling you about the f of x's and the g of x's and all that sort of thing here, because I don't want it to be clear yet on how many functions are in here, how many functions are composed. So the directions are going to be to define the functions that have been composed. That's what we've been doing before. And also to rewrite the right side of the equation using function notation. So what that means is basically you take something like this and you make it look something like that, the f of g of blah blah blah. Okay, so let's break this down. Let's see, y equals 3x squared plus 4 to the 5th power. So we're looking for the largest box we can draw. We see a power function right there. So we do have an outside. That's box to the 5th. So let's define that as f. We could call it anything we wanted, but f is fine. F of x equals x to the 5th. And then we also have an inside here. Three x squared plus 4. Now notice here's another power function right there. But if I draw my box, notice how there's only x in it. If there's only x, then it doesn't need to have its own function. So rather than doing anything with it, this is just our endpoint. So let's mark here only x, so doesn't need its own function. So in this case, we've got one outside function and one inside function. So that's just like these ones that we were doing earlier. F of g of x. We're going to define this as f of g of x equals 3x squared plus 4 to the 5th power. So this, and this are all part of our answer. Let's have you check your understanding for this on a similar problem. If y equals 4 to the tangent of x, define the functions that have been composed and rewrite the right side of the equation with function notation. Okay, pause the video, try that one, and restart the video when you're ready. Our biggest box function is right here. We have 4 to the box. Let's call that f of x, or f of box. So there's our outside function. We've got an inside function, tangent of x. Now notice that we do have a box function here, but only x is inside it, so we don't need our own function. We can just stop there. That can be g of x. And once again, we have f of g of x equals 4 tangent of x. The final piece is that sometimes we have more than just composition going on. Sometimes there can be multiplication or division as well. So here are going to be general instructions. For each function, define the functions that have been multiplied, divided, or composed and rewrite the right side of the equation using function notation. So these are the same directions as we were doing earlier. It's just now we're going to have some slightly more complicated equations. So for our first one, let's do y equals 3x sine x. Now, first thing we're going to look for is box functions. But if you notice, this just has x in it, and this is not a box. However, something's clearly going on here, because 3x and sine x, there's 2 different variables in there, and it sure looks like they're being multiplied together. This is really y equals 3x times sine of x. Notice that that multiplication symbol is not necessarily written. It's sort of invisible. It's kind of implied. So what that means is it means we can just have these 2 separate little functions. Let's say this is just the one on the right. Let's call it whatever we want. H of x, q of x, g of x, f of x, anything. Let's go for q of x. And we have this other one over here. Let's call it m of x. Really does not matter what these are called. Anything you want. So that's part of our answer, so I'm going to circle or put a box around that. And those are multiplied together. So what we're going to say is we're going to say that q of x times m of x is going to give us 3x sine x. Which makes a great deal of sense. 3x times sine x, lo and behold, 3x sine x. Let's do another one of those. Y equals 3 x squared plus 3x minus 1 squared over sine of x. Well, notice here we pretty clearly have some division. So why don't we just take this one over here just for starters. We've got a bottom. Clearly something equals sine of x. Let's call it n of x, just for kicks. This part up here now, we can see we do have a box function. There's this squared here. And so that means that up here we do have an outside, which is 3 box squared, so let's call that f. And we also clearly have an inside function. X squared plus 3x minus 1 is what's in the box. Notice again we do have a box function here, but there's only x, so it doesn't need its separate function. Okay, so we've got 3 little pieces broken down. Now we just have to say how they go together. We can clearly see, here's our function, it's 3x squared plus 3x minus 1 squared over sine x. We can clearly see that this denominator, sine of x, is this n of x piece right here. Up on top we can see we have an outside function, that's f, and an inside function, that's g. So what we should have here is we should have this g of x gets put into the f of x. That gives us 3x squared plus 3x minus 1 quantity squared. That's our numerator, whole numerator. And then divided by n of x, or sine of x. One last problem. Let's do a check for understanding. Let's make our function y equals 10x e to the cosine of x. Go ahead, pause the video. Okay. So what we see here is I do see a box function, but I also see this part right in front that's being multiplied times e to the x. So I'm going to put in the little multiplication symbol right here, and I'm just going to separate these two pieces. So over here we've got, let's call it q of x again. That equals 10x. Then that's being multiplied by the stuff over here that's got all our box functions. So outside, got e to the box, f of x equals e to the x, and then inside, cosine of x. Notice that this is a box function, but there's only x, so it doesn't need to go any further. G of x equals cosine of x. So that means that with this function 10x e to the cosine of x, that can be written using function notation as q of x times, we have an outside and an inside, so that's f of g of x. That concludes these notes.